9.1, number 19. Differential equation here, 2y prime plus 5y equals 4. Again, kind of a weird one because we see a lot of addition and subtraction here. And you have a y term here on the left side, which seems like a good deal. But because that's addition, this is actually a pretty difficult problem. So the first step we're going to do actually seems counterintuitive. We're going to take this 5y and bring it over here to the right-hand side by subtracting it. Getting 2y prime is equal to a 4 minus 5y. If we could factor this expression, we would do it right now, but we can't, so we basically want to think of that as one big factor here. And now, for the next step, we're going to take this entire factor, the entire right side of 4 minus 5y, and divide by it, bringing it over here to the left-hand side, making it a 1 divided by that 4 minus 5y. The dy from the numerator of the y prime stays. We want to move the 2 out of the way, so we divide both sides by 2. That's where the 1/2 comes from. And the dx that was in our denominator here gets multiplied and becomes a 1/2 dx on the right. So that's a little bit unusual compared to everything else we've done in terms of how to separate your variables. But now that we have it, we're ready to go ahead and do an integral on the left-hand side and an integral on the right-hand side. And notice what we're doing here, even though the format looks a little bit different, we're taking an integral of a constant divided by a linear function. So that's going to give us the natural log of the absolute value of the denominator, the 4 minus 5y. But remember then, you have to divide by the derivative within, which is negative 5, and that's where the negative 1/5 right here comes from. The right side's much easier. It's just going to be a 1/2 x and a plus c. There's no initial condition to deal with here, so we keep going and trying to get y by itself. First thing we have to do is to get rid of the negative 1/5, and we'll do that by multiplying both sides by negative 5. So a negative 5 times the 1/2 x is going to get us a negative 5/2 x, but remember that a negative 5 times a constant is still just a constant, so that one we can just leave as plus c. Now we're going to undo two things at once. We'll get rid of a natural log by exponentiating both sides. We'll get rid of the absolute value by putting a plus or minus there in front of that e. So we end up with a 4 minus 5y is equal to a plus or minus e to the entire right side as its power. But remember, if you're trying to match the book's answer, even though this is okay, they usually break this up now and make it plus or minus e to the negative 5/2 x multiplied by e to the c, remembering that e to a constant power is just going to be a constant in and of itself. So that's where this comes from. Also at the same time here, I subtracted the 4 from both sides. So that left me with a negative 5y equals. And since this factor right here simply becomes a constant, that came out in front. The plus or minus e to the negative 5/2 x, well, there's the e to the negative 5/2 x, but the plus or minus is irrelevant because we have a constant in front of it, which could be either positive or negative. And that 4 that was out in front on the left side now becomes a minus 5 at the end. And a couple of different forms for where you could have gone next, but to get their answer, the book simply divided each term individually by negative 5. Remember, though, that a constant divided by negative 5 is still a constant, so it doesn't look like there's any change here, and that negative 4 gets divided by that negative 5 to make a plus 4/5.